Hi everyone, let's go to question number 17. Problem 17. It says 4x minus 9 equals 7. Okay, so 4x minus 9 equals 7. Right, I need to isolate the variable again. So that becomes 4x equals 7 plus 9. And 4x equals positive 16. So x equals positive 4. So now we've done enough of this material, we kind of see what's going on. Now, in this example, we just want to see what we have learned actually works in this example too. Do you notice that 4x can be written as even number? Is that even number? Let's just try to think about whether it is even number or not. In order to tell whether it is even number, well, it should be written as 2 times something. So let's just try to investigate a little bit more further on that 4x can be written as 2 times 2x. And as long as it can be written as 2 times something, we call them even number, okay? So that must be even for sure, right? So I got even number, and I'm subtracting with some odd number. So we get even number minus odd number. Well, that must be odd number for sure. Why? Because if you rearrange all these like letters, you can check that odd plus odd got to be even. Because we know that this is true. Hey, because that's true. All right, so that being said, we understood what has happened right now according to the parity. Right? I told you that these are true by parity, right? What about 4x minus 9 divided out by 4? Oh man, if it's divided out by 4, I need to get a remainder of 3 because it seems like 7 leaves me the remainder of 3. And I get an integer solution. So in order to get an integer solution, the remainder's got to be same if I divide it out by 4. All right, so check this out. 4x minus 9, in fact, equals 4 times x minus 2 minus 1. Well, that seemed to be the most, like the closest one that I can get. Because it seems like 9 is really close to 8. So I actually find it out in that following form. But the problem is negative 1 is not necessarily the remainder. So what do I need to do? Even though it's counterintuitive, it's not really counterintuitive. We're just kind of going one step further, right? So if you go one step further, it becomes 4 times x minus 3. And I'm subtracting 4 out there. That becomes extra 4 out there. That becomes negative 12. And I got negative 12 and negative 9. The common difference got to be positive 3, I would say. So it is positive 3. And if you think about it very carefully, if I go down by 1, I need to somehow get extra 4. That makes sense. It's kind of like giving you a brief structure of something called Diophantine equation. Later on, we're going to learn about integer equations in those like math competitions, like middle school competitions and high school competitions. But again, we're kind of looking at what has happened if I subtract 1 inside in those parentheses, open parentheses. I got always a string of 4 that is coming out, okay? So we got a remainder of 7. We got a remainder of 3 when divided out by 4. And of course, you can check that 7 equals 4 times 1 plus 3. And we can check that the remainders are all equal to one another. So that's really good because we get an integer solution, x equals 4, and that shall be it.